Hi, this is Ms. Triangle, and this is a video on rational and irrational numbers. So you will need a pen or pencil, something to write with, and a piece of notebook paper. So what you're going to do once you have your notebook paper is first you are going to draw a line with your pen or your pencil that goes horizontally straight across the top. Then you are going to skip 2 lines and draw another horizontal line like this. And you do that same thing, skip 2 more lines, 1, 2, and another sideways horizontal line. So you should have 1, 2, 3 horizontal lines, and then you're going to make a vertical is up and down, a vertical line like that. So take a second to set up your notes and we'll get started. So your piece of paper should look like this, and we're going to start filling this in. So you are going to start by listing the topic. So I'll circle that, the topic, 1 rational versus irrational numbers. And I used the hashtag symbol here, which is an abbreviation for numbers. So take a second, and in that top, you are going to write the topic. Then you are going to write essential question, and I always tell students if they want to abbreviate and just write the letters EQ, that would be fine. So you don't have to write out the whole phrase essential question, but EQ, and then you're going to highlight that, and then you're going to copy, it doesn't have to be in red, but you're going to copy our essential question for this lesson. What are rational and irrational numbers? So that is the whole point of this video and this lesson, is to learn what a rational and what an irrational number is. So if you need to pause the video, if this is going too fast, you always have that option. Then you are going to write learning target. Again, if you want to abbreviate and put LT1A, that's fine, but you need to put 1A, LT1A. Okay, this is the first learning target of Unit 1, and here it is. I can determine and explain. So not just say yes or no, but also explain if a number is rational or irrational. So that is the goal for this lesson, this video, and what you should be able to do by the end of watching this. I can determine and explain if a number is rational or irrational. So then we're going to move on to the vocabulary. Our first vocabulary word is rational number. If our goal is to determine what a rational number is, we need a definition. So the official definition, if you were to go on Google or a dictionary, you would see the definition of a rational number is a number. I'm going to zoom in here a little bit. That can be written as a fraction. So that's the official definition, a number that can be written as a fraction. And the word part, just so you know, ratio in math means a fraction. So it's a number that can be written as a fraction. Okay, we are going to elaborate a little bit more just because there are many numbers that may not look like a fraction, but are still rational, and I will explain. So you do need all of this, everything I'm writing on this slide, you also need to be writing. So I'm going to say an integer. So an integer, people think it's a whole number. That's sort of true, but they can be positive or negative. So any integer like -3, 0, 1, 7, these are all rational numbers. So they're going to look like one plain number and not a fraction. But remember, any number like the number 2 can be written as a fraction by saying 2/1. So an integer, if you see an integer, that is a rational number. Okay, my second bullet point, probably this one will seem obvious, but is a fraction. Okay, so any fraction, 1/2, a mixed number, 1 2/3. Okay, a negative fraction, those are all rational numbers. Any fraction, for our purposes today, any fraction is rational. So that was my second bullet point. So we had integer, we had fraction, we have 2 more. My next bullet point, okay, is a decimal. I'm going to zoom in a little. A decimal that terminates And if you're not sure what the word terminates means, that terminates or stops. Okay, a decimal that terminates or stops. A little crooked. Okay, so what we mean by that, I'll give a few examples. Maybe something like 0.5. That is a decimal that stops, right? It doesn't go on forever. And that can be written as a fraction. 0.5 is the same thing as 1/2. So any decimal that terminates or stops, even if it looks a little long, it can be turned into a fraction. And it is rational. All right, the last bullet point is a decimal with a repeating pattern. A decimal with a repeating pattern. And I'll give you a couple examples for that. So let's say you have something like 0.33333, and a lot of times how we'll write it is with that little line over to show that it goes on forever, 0.333. That can still be written as a fraction. You might be familiar with this one, 1/3. Okay, so just to recap what we learned on this page, we learned the definition of a rational number. It is a number that can be written as a fraction. A number that can be written as a fraction. That does not mean it will always look like a fraction, but it can always be turned into a fraction. So how will you know? You can look for these 4 things. 1, an integer, a whole number. -3017, any fraction. A decimal that terminates or stops. A decimal with a repeating pattern. So those are the 4 ways that you might see a rational number. Vocabulary. So a decimal that ends, a decimal that terminates or stops, I see right here, that is a rational number. So when I go to and see was fraction, yep, fraction was one of my 4 bullet points that was a rational number. Your notes, a decimal with a repeating pattern right here, my 4th bullet, that is rational. All right, we are gonna, it might seem off topic, but we're gonna talk about perfect squares. And if you're able to do this in person, you'll be getting this chart to glue in. If not, you're gonna wanna take a minute to write down this perfect square chart because we're gonna be using it all year. So it's very important that you write it down, square roots. I generally tell people, and I don't expect it to be instant, but you do want to memorize this perfect square chart, 1 through 15. Okay, so the square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. And it kind of goes the other way. 5 squared. 5 times 5 is 25. So all the way up through 15. So make sure you take a minute to copy the perfect square chart 1 through 15. If you need to pause the video, please feel free to do that. Okay, so what is an irrational number? So I don't like to tell students to guess because I do want them to know, but if you have to guess, most numbers are rational. Most numbers are rational. Okay, it is rare, more rare that a number is irrational. So what is an irrational number? Well, it's a number that cannot be written as a fraction. Okay, and a little more specifically, because I think that doesn't really help students a lot, this official definition, generally you're going to be looking for a few things. Okay, generally it is a decimal with no pattern. So if it has a pattern, then it's rational. We learned that on the last side. With no pattern, and it has to be both, and that goes on forever. So a very common example that you may have heard of for a irrational number is the number pi. Okay, that is 3.1415926, and that goes on forever with no repeating pattern. So that would be an irrational number. Another common way we see irrational numbers, and the reason why I put this square root chart, is what is called, I'll make a bullet point here, and I'm going to zoom in just for a second, okay, is non-perfect square roots. So for example, the square root of 3, if you were to type in on your calculator the square root of 3, so if you were to type that in, it would give you something like 1.7320508, on and on and on and on. Or something like, let's try the square root of 7. Okay, that if you were to use your calculator is going to be 2.64575, on and on and on. So what do you notice about all of these numbers, including pi, square root of 3, square root of 7? They are all decimals with no pattern that go on forever. All right, now you need to, because we're not using a calculator for this section, you need to be able to tell if something is going to be a non-perfect square. So that is the point of this chart. If you see one of these numbers under the square root sign, like square root of 1, oops, that's a little hard to see. I'll erase that. So if you see something like square root of 1, square root of 4, square root of 9, any of these numbers, these are going to be rational numbers because they equal an integer, a whole number. So if it's not one of these numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, if it's not one of these under a square root, like square root of 3, square root of 7, it is irrational. Look back at example, look at my notes. So please look back. So that was on this chart. I'm looking, and remember when you use this chart, let me erase it so it's a little easier to look at. When you look at your perfect square chart, you are looking at the numbers underneath the square root. So I'm looking here. 1, 4, 9. I do not see a 6. 1, 4, 9, 16. So I'm not looking at this 6 here. I'm looking at the numbers under the square root. Since 6 is not under the square root, it is not a perfect square. So it is